Students, okay, in this session, we will discuss the serial communication registers of 8051 and show how to program them to transfer and receive data serially, right? Okay, so the 8051 has a serial data communication circuit that uses register called SBAR to hold the data. It uses register SCON to control the data communication, and register PCON controls data rates, and pins RxD and TxD to connect to the serial data network. Okay, so we will discuss all of them in this session. So by the end of this session, you will be able to describe serial communication in 8051 and its associated registers, programming 8051 for serial communication, and analyze some example programs. Okay, so many IBM PCs, that is computers, are widely used to communicate with 8051 based systems. That means the serial data communication via from 8051 to PC or PC to 8051 based systems. It has wide applications. Okay, so in order to allow data transfer between the PC and the 8051 system without any error, we must make sure that the baud rate of both the systems should match. Okay, and I hope you remember what is baud rate. Baud rate is nothing but bits per second, right? So the rate of transfer of data, that is number of bits per second, from or to PC to or from 8051 base system, both should be matching. All right. So in order to examine, to know the baud rate of a particular PC in a Windows, you can go to you can open hyperterminal program, clicking on the communication settings there in the option there, then you will come to know the baud rate of a particular system or the PC, right? So once you know that, you can rearrange or change the baud rate of 8051 microcontroller system which you are connecting to the particular system or the PC. Okay, so here is the list of few baud rates supported by Pentium IBM PCs. Okay, so these are the different, it can be 110, 150, 300, up to 1900, 200. But the baud rate supported by the recent PCs will be quite higher than the list shown here. Okay, so the baud rate in 8051 is programmable. What does it mean? That means you can change the baud rate of 8051, right? So how to do that? Observe here. In order to set the baud rate, we use the timer 1 of 8051. Okay, that means in order to set the baud rate for serial communication, we use timer 1. Okay, how do we use that? Well, I'll explain you. Now you see here the crystal frequency, that is 8051, divides the crystal frequency by 12 to get the machine cycle frequency, right? So if the crystal connected to 8051 is 11.0592 megahertz, then to get the machine cycle frequency, we will divide it by 12. So we get 921.6 kilohertz, right? So this machine cycle will be divided further by the 8051 serial communication UART circuitry by 32. Okay, understand here, the 921.6 kilohertz machine cycle will be divided further by 32 by the UART circuitry of 8051. Okay, what you get there? You get 28,800 hertz. So this frequency will be used for serial communication. All right. So this value, that is number of clock pulses here, number of clock pulses will be loaded onto the timer 1. All right. So when you are using timer 1, we have to use timer 1 and program it in such a way that it will be operating in mode 2. Okay, mode 2 means what? Timer 1 will be operating in mode 2 means it is 8-bit auto reload method, right? Auto reload. So recall, in auto reload we load the initial value in TH1 register of timer 1, correct? So that the same value will be used by TL1 register. So once a timer is started or it starts ticking, then TL1 will be incrementing or counting up. Okay, so when we are using timer 1 to hold the frequencies, that is providing the baud rate for the serial communication, then we'll be loading the initial value in TH1 register. Okay. So when timer 1 is used to set the baud rate, it must be programmed in mode 2. So to get the baud rates compatible with the PCs, we must load the following values as shown in the table below here for different baud rates. All right. Say according to the system, like if you want the baud rate 9600, then the frequency what you are getting 28,800, you have to divide it by 3. So this decimal value, that is -3, can be loaded in TH1 register, or FD in hexadecimal will be loaded into TH1 register. So if you want 2400 as your baud rate, that means you have to divide 28,800 by 12. So this -12 will be loaded in decimal if you want to load it in decimal into the TH1 register of the timer 1, or its hexadecimal F4 will be loaded into TH1 register. Similarly, if you want the baud rate to be 1200, then you have to divide 28,800 by 24 to get 1200. Okay, so -24 in decimal, you can load it into TH1 register, or its hexadecimal value E8 can be loaded into TH1 register. So that is how we will be using timer 1. Okay, so the initial value, all these initial values, FD for baud rate 9600, FA for 4800, F4 or E8 will be loaded in TH1 register of timer 1. So timer 1 will be operating in mode 2. Okay, that is how we will be using for serial communication. I'll explain what does this signifies as we go on in the further slides. So as I said, a serial communication in 8051 uses a register called SBUF. SBUF is a 8-bit register. So when you want to transmit data, so the 1 byte of data will be held in SBUF. So that will be transferred via TXD line. Okay. Or if it is if you are receiving serially, then there is one more SBUF register which will be holding the 8-bit or 1 byte data which is received serially. Okay. So while transmitting, if you have a byte of data that has to be transmitted, then SBUF, which is holding the 8-bit data, so then it will be framed with start and stop bits and then sent serially via TXD line. So when you are transmitting serially, okay. At the same time, when you are receiving serially, so you will be getting with start and stop bits along with your 8-bit data, right? Remember data framing. So you will, the data will be serially coming in, starting from the start bit, followed by 8-bit data and one stop bit. So the 8051 deframes this, eliminates the start and stop bits. Then 1 byte of data will be placed in the SBUF. Okay, so you can imagine SBUF to be at transmitting line and receiving line as well. All right. So SBUF register can be used like any other register. So few examples are shown here. See, you can load immediate value into SBUF, or you can load from accumulator, or the content of SBUF can be moved to accumulator. Few examples are shown here. So SBUF is exactly a physically two registers, two 8-bit registers. One register which I told it will be at TXD line, it is write only register. Okay. So it is used to hold the data that has to be transmitted via TXD line. The other register is read only. So the data which is coming serially, after deframing, you will get the 8-bit data which is read only. So that will be at RxD line. Okay. So these both registers have same address 99H, and it is not bit addressable. Okay, the next register that is used in serial communication is SCON register. It's a 8-bit register, and it is used to program the start bit, stop bit, and data bits of while data framing. Okay, and along with other things. So other things are here shown as different bits here. So just first go through these bits, then I'll be explaining in the following slides what each bit mean. Okay, so SM0 starting from MSB this side, left hand side, MSB bit, and the next SM0 and SM1, they are the serial port mode specifiers. That is, in which mode is serial communication operating. Okay, SM2 is the bit which is to specify used for multiprocessor communication. REN is set or cleared by software to enable or disable the reception. TB8 and RB8 are not widely used, so we will not discuss much. Maybe I'll explain in the next slides. TI and RI, it is transmit interrupt flag. TI stands for transmit interrupt flag. It is set by hardware, that is at the end of, beginning of the stop bit. So end of the transmission, beginning of the stop bit, the TI flag will get set, but it is cleared by software. Okay. So RI also, it is a receive interrupt flag set by hardware at the beginning of the stop bit and cleared by software. I'll explain them slowly. Okay, so SM2 bit is D5 bit of SCON register. This bit is enabled to indicate that multiprocessing capability is enabled. So it is not used here. It is not widely used. So we will restrict our explanation here. So in our understanding, SM2 has to be 0 since we are not using 805 in multiprocessing environment. Okay. SM0 and SM1, as I said earlier, it decides the modes, serial communication modes. Okay. So when these two bits are 0, 0, then serial mode 0 operation. 0, 1 is mode 1 type of operation. 1, 0 is mode 2. 1, 1 mode 3. So see here, we are only interested in mode 1. Mode 0, 2 and 3, it is not used and it is not of interest. Okay, so we are interested only in serial communication operating in mode 1. Why? Because in mode 1 it makes it compatible with the comport of IBM compatible PCs. That is, when you are programming 8051 microcontroller operating in mode 1 of serial communication, then it means that that is the mode which is compatible with comport of the IBM PCs. All right. So here, when serial mode 1 the baud rate will be variable. So it provides variable baud rate. So you will understand again when we discuss further slides. So it provides variable baud rate. That means you can change the baud rates. Remember in the previous slide I told you you can change it to 9600 or 2400 or 4800. So we can vary the baud rates. So that is possible when you are programming serial communication to operate in mode 1. Alright. So it provides variable baud rate, and that will be used by the timer 1 of 8051. Okay. So when you are programming in mode 1, it means the characters that you are transmitting or receiving, it will be of 10 bits, which means there will be one start bit, one stop bit, and 8 bit of data. Okay, that's what the meaning. Okay, further, REN bit. REN is bit addressable. So REN stands for receive enable. D4 bit of SCON register. So when it is high, it allows 8051 to receive data on RxD line. Okay. So that means if it is low, that means you have disabled any receiving of data serially. Why? Because see, transmission can be controlled. Okay. Reception is not controlled. When you are transmitting data, it is you that will be sending the data from 8051 based system to any PC. Okay. So when there is any connection between 8051 microcontroller and any other PC, so reception is not controlled. Okay. Controlled in the sense like if there is connection, then if the PC is sending data, then that would be coming via RHD line. So to control that, this REN line is used. Okay. Only when it is made high, the reception will be allowed through RxD line, and if it is made low, then you are just restricting it, and no information will be coming via RxD line. Okay. Then TI transmit interrupt, as explained, 8051 after finishing 8-bit of the data transmission, the TI flag will be made high. It becomes high to indicate that the data has been transmitted. Okay. So it's a hardware control, in fact. So once the 8-bit data is gone and halfway through the stop bit, the transmit interrupt flag will become high. Okay. So that has to be monitored. Okay. Then using software, we have to clear it. Okay. That is the meaning. In the previous slide, we said it is hardware. It is enabled by hardware and cleared by software. That's the meaning there. So similarly, the receive interrupt, when the 8051 receives data serially via RxD line, it gets rid of start and stop bit and places the byte in SBUF register. So it raises our I flag to indicate that a byte has been received and should be picked up before it is lost. Okay. So even here, the receive interrupt will become high, that is set by the hardware itself at the halfway through of the stop bit. Okay. So it becomes high and it has to be cleared by the software method. All right. So again, this helps us see when transmitting or receiving, this helps us to avoid overwriting in transmission or junk of garbage data coming in. Okay. If the data has come in and if we have not read it or received it, then maybe another set of data would be coming and falling into SBUF register. So in order to keep track of that, these interrupt bits are used. Transmit interrupt and receive interrupt bits are used. So programming 8051 to transfer character bytes serially. So if you want to transmit data serially, then what are the steps that has to be followed? Okay, so the first step is load your T mode register with the value 20H, indicating that you are using timer 1 in mode 2. Okay, so that value has to be loaded into T mode register. Then according to your baud rate, what you have decided, so that initial value has to be loaded in TH1 register of timer 1. Then SCON register has to be loaded with value 50H, indicating which mode, that is generally it is mode 1, right? So indicating serial mode 1, where you have 8 bit of data, 1 start bit and 1 stop bit, right? Then the fourth step will be start the timer. So when you start the timer, the initial value that you have loaded in TH1 register, so from that value, the timer starts ticking or starts counting up. Okay, so when it starts counting up, you are having number of pulses there, number of clock pulses there, right? So that every clock pulse, the data will be transmitted. Okay, every bit. All right, so every bit for every clock pulse, the data will be transmitted. Once the timer reaches maximum value, what is its maximum value? FFH, because it is a 8-bit register. When it reaches FFH, in the next clock pulse, it rolls back to 00H. So when it rolls back, what will happen? The overflow flag will get set, isn't it? So overflow flag has to be monitored. Also, to monitor the data transmitted serially, you have to monitor TI flag, TI, transmit interrupt. So when transmit interrupt goes high, what does it indicate? That means all the 8-bit data has gone, okay, and halfway through the stop bit, the TI will get set, isn't it? So that has to be cleared. So you have to monitor and you have to clear that. Okay, so the character byte, where is it now? It is sitting in SBUF register, right? So SBUF is holding your 8-bit data. So that has to be serially transmitted. So TI flag will be monitored using instruction JNB TI, comma, again or here, whatever, according to your convenience. And if required, repeat the steps from 5. So we will look into a program and we'll analyze this. Okay, observe the program here. Let us analyze. Write a program for 8051 to transfer letter A serially at baud rate 4800 continuously. Okay, so continuously you are sending capital A serially. So observe instructions. First, you are loading T mode register with 20H. That means you are programming timer 1 to operate in mode 2, auto reload mode. Then you are loading the initial value, that is the baud rate, in TH1 register. Since it is 4800, so you can either load the decimal value -6 or you can load the hexadecimal value FA, right? So that is loaded into TH1 register. Then you are loading SCON register with 50H, which means that you are programming SCON register 50H. You write and see how does it look. 011101 000. That means the lower nibble RI, TI, RB8, TB8 all are zeros. TB8 and RB8 are not at all used because they are used only when you're using mode 2 and mode 3 of serial communication. So they are not used here because we are discussing only mode 1 of serial communication. Okay. Then the upper nibble, it is 0101. That means SM0 and SM1, you are making it 01. Okay, that is mode 1, correct? Then SM2, obviously it has to be 0 because you are not at all interested in multiprocessing of 8051. Then REN is made 1. REN is made 1 means receive enable. You have just enabled the receive. Since you are now transmitting, even if it is made 0, that doesn't make any difference there. Alright? Okay. Then set bit TR1. So you are starting the timer. The timer starts running, counting up, right? Observe. In again, what are you doing? Move SBUF, comma, hash, capital A within quotes. So when within quotes means we know, remember, this is the type of data. Then what will happen there? The ASCII code of this character within quotes will be moved on to the destination register. Remember, I had explained. Okay. So the ASCII code of capital A is 41. Remember? So 41H will be moved to SBUF register. Okay. So in this loop, observe here what is happening. Okay. Now already the timer is ticking. That means now for every clock pulse, this 41 in SBUF has to be transmitted, right? So you are keeping, what are you keeping track now? You have to observe the transmit interrupt flag. Okay. Now you are not monitoring overflow flag. Observe here. You are concentrating on the serial communication. So now you are interested only in the transmit interrupt flag. So GNB TI, comma here. That means till TI is not set, then be here. That means you are polling. You are waiting for TI to be high. When it is high, you come out of the loop, make it 0, clear it, then repeat it. S jump again. So that means same again, A, which is in SBUF, will be transmitted. So SBUF is holding 41 your data. So when it is transmitted, so while transmitting via TXD line, the start bit, 8-bit data, and stop bit will be considered. That is, framing will take place. So first start bit will go, then followed by your 8-bit data, then the stop bit. So halfway through the stop bit, TI will be made high by the hardware circuit. I hope it is clear. Understood? Just go through. Please, every slide, please repeat the explanation, understand, and then proceed. So what I explained in the previous slide, it is shown here. The steps that 8051 goes through in transmitting a character via TXT line. So first, the byte of character to be transmitted is returned into SBUF register. The start bit is transferred, followed by the third step, 8-bit character that is transferred on bit at a time. Okay. Fourth step is stop bit is transferred. Halfway to the stop bit, the TI flag will be made high, indicating that the last character was transmitted. And step 5, by monitoring TI flag, we make sure that we are not overloading SBUF. So we have to keep track of TI. So once TI is high, then we have to clear it, and if required, repeat the same process. Okay, analyze this program. Write a program for 8051 to transfer YES serially at 9600 baud rate, 8-bit data, 1 stop bit. Do this continuously. Okay. So how do we start? The first step is load TMOD register with 20H. 20H meaning timer 1 operating in mode 2. Then you are loading the initial value into TH1. TH1, it is loaded with -3 in decimal, or you can load FD in hexadecimal in order to set the baud rate to be 9600. Okay. Then SCON register you are loading with 50H. So 8-bit of data, 1 stop bit, and REN is enabled. Okay. set bit TR1, that means start the timer. So for every clock pulse now, the data will be sent. For every bit, one bit of data will be sent. Every pulse, sorry. Now move a comma y. So when it is within quotes, the ASCII code of y will be copied into a register. Then you are saying a call trans. So you are calling the subroutine called trans. So subroutine is here, serial data transfer subroutine. So what happens here at this juncture? The contents in A is copied to SBUF. Okay, then that will be sent, right? Serially it is transmitted via TXT line. You are keeping track of TI, transmit interrupt flag, so till it gets set. So for now, observe here, the timer is ticking. It is counting up. For every clock pulse, one bit of data will be transmitted. After 8 bit, the stop bit will come. Once the stop bit, half through the stop bit, the TI flag will be set. So once it is set, you're out of this loop, that is here loop, then you have to clear it. Remember, this is very important. Once TI is set, so using software we have to clear it. Okay, return means it will go back here to the main program. Next, move a comma e. So you have sent y, now you have to send e. So same subroutine will be used. Okay, after return it will go back there. Then you will move s, again calling the subroutine. Then s jump, that means it is repeated every time serially. YES will be transmitted serially. So in order to observe this, maybe you can connect a seven segment display. So there again, you have to use one more program where the data transmitted can be displayed somewhere. All right.